Yeah, but why is it important?
The point of reallocation of resources of any resources between the two parties or economic entities involved, and that is important because the whole idea of economics is welfare maximization with minimum resources alone. So,
Equilibria have certain nice welfare properties, that's important. But why do we always model behavior as it? So why not simply say that the common sense tells us that quantity demanded will depend inversely on price, so collect data on demand, collect data on quantities, collect data on prices, do a regression, and you will get whatever quantities you want, right? You want price elasticities and all that. So you will to find out from that. Why not simply do an empirical exercise? Why do we need this theoretical model? So I think what all of you are saying is the following. I'll give you an example of why all this became important. You remember the Phillips curve? You remember the Phillips curve? What does the Phillips curve say? Inflation, unemployment. Yeah? And Mr. Phillips found this on the basis of looking at data. He said that data shows such an inverse relation. What does it mean? It means that if you try to reduce unemployment, inflation goes down. If you try to reduce inflation, unemployment goes up, so there is a trade-off. And it seems to be a stable trade. Right. Now why does this trade-off exist? Why does if you reduce unemployment, why do you have to settle for high inflation? If you reduce unemployment, why would I have to settle for higher inflation? So you have to increase demand in the economy. If you increase demand in the economy, unemployment goes down, inflation goes up. Right? Now look at what's happening. If the demand in the economy goes up, suppose it happens through a expansionary monetary policy. So if money supply expands, what happens? All the prices go up. Right? Sure? So if prices go up, if you want the demand for labor to increase, the real wage for labor should fall. Only then will the demand for labor then will the demand for labor increase. So if there is an expansionary monetary policy and if prices are increasing, you want money wages of labor to stay constant, right? You want the money wages of labor to stay fixed or not increase as much as the prices do, which will mean that as monetary policy expands, real wages will decline, there will be greater incentives for employers to employ labor and unemployment will go down. Right? That seems to be the logic. So now this logic is critically dependent upon money wages not changing as much as prices. Yeah? And it's a fact of life that money wages don't change as much as prices. Right? Why do money wages not change as much as prices? There are various reasons. For example, many money wages are based on contracts. That this is the salary that you will get. But it's costly to renegotiate contracts every time. Renegotiating contracts might sometimes take longer, then the prices can increase, but for people to realize that their wages have fallen, that their money wages are not buying as much as that used to earlier, and so sit down with their employers and ask for a new revised money wage and all that takes time, right? And therefore you get this. Now the point is, so if for a long time it was assumed as an empirical fact that money wages don't change, right? But money wages will not change. For example, workers will not renegotiate money wages if the price changes are small. But if the price changes are huge, then workers might want to renegotiate wages quickly. Right? So therefore, whether workers renegotiate wages or not renegotiate wages depends on how large the money supply change is. For large money supply changes, therefore, what might actually happen is, because prices are now so high, workers want to change their money wages very fast, and so money wages might rise just as much as prices do, so real wages would stay where they are, and therefore the amount of unemployment would stay where it is. So unemployment will not change, right? Even if even if the inflation rate changes, because you'll have higher inflation, right? So it means that if money wages are willing to change fast, you'll actually have a straight line. That's the vertical Phillips curve, right? That's all of you must have studied that. The key point is therefore whether people negotiate wages or not renegotiate wages depends upon what the price change has been. For small changes, people might not negotiate. For large wage changes, people might want to renegotiate wages. Which means that whether this relationship is a stable relationship or not depends upon how large the policy changes. Different types of policy changes might actually lead to different behavioral changes, and therefore those underlying relationships themselves might change. And then policy making will become very difficult. What is the point here? The point is that behavior is changing, underlying behavior is changing. We are assuming some behavior empirically given, and then there is a policy change, and then there is a behavioral change. But because we have no way of modeling the behavioral change explicitly, right? Okay, the underlying structure of the economy will actually change, and therefore your policy might actually not be right. Your policy might no longer continue to be right. Right? So large changes, right? Okay, this was the Lucas critique. Okay, Robert Lucas said that this is the problem with this kind of a modeling of macroeconomics, where you assume that there are some empirical regularities which are stable. They might not be stable, they might change with policy, right? Okay, and therefore if you want to really understand how a macroeconomy works, you must explicitly model people's behavior. You explicitly model people's behavior by saying, by arguing that the economy consists of rational utility maximizing individuals. Then you say this is the price, you might not renegotiate change. When the price goes up, then you might want to renegotiate as an outcome of an equilibrium behavior. Right? Okay? So therefore it's important to ground policy, our understanding of the economy specifically in terms of individual behavior. And therefore you will find a lot of macroeconomics now actually derives itself from microeconomic foundations. They will say that this economy consists of so many individuals. These are the constraints that the individuals are facing. These are the change in prices or incomes. Then this is how the aggregate, the individual behavior will change. So the behavior of all the individuals in the economy will be the aggregate of all these individual level changes, right? Okay, which is called individual based modeling. So most of macroeconomics now individual based kind of modeling, and you will soon do that kind of macroeconomics when you go to the second semester, where you have utility maximizing individuals, you're maximizing utilities over many generations. So you will have overlapping generations and dynamic general equilibrium, stochastic dynamic general equilibrium models, the DSG. Have you heard of this? Dynamic stochastic general equilibrium models, right? So that's how you actually understand macroeconomics in a more general equilibrium. So you understand the macroeconomy as an interconnection of several individuals, markets, which are interlinked through utility maximizing, profit maximizing kind of behavior. And the whole thing is also subject to shocks. So you have a general equilibrium model, which is stochastic, and which is dynamic. We look at the paths between equilibrium, right? So that is the kind of macroeconomics that everybody does nowadays. It's called dynamic, stochastic, general equilibrium, DSG, the DSGE kind of model. So therefore, to either to do microeconomics or macroeconomics, you must have fundamental grounding in people's behavior, and that is utility maximizing behavior.
Actually, government is trying to expand money supply, but still the demand is not picking up because of the psychological behavior of the people over there.
Yes. So different kinds of policy changes might lead to different behavioral changes, right? Unless you model those kinds of behavioral changes, that's why policy is so difficult, because the economy is a very large complex mechanism. People have all sorts of motivations there. We have no clear idea what their motivations are. So when we make a large change, a lot of behavioral adaptations happen, and therefore the outcome of the large policy change might be completely different from what was envisaged in the first place, right? Therefore we try to get as good a handle on people's behavior as possible, right? That's what we actually model individual agents, right? That is why. So basically you have to therefore be very strong. If you want to be an economist, you have to be very strong at the envelope theorem, Roy's identity, Shepard's lemma, deriving demand functions, right? Deriving supply functions from utility maximizing agents, right? Hoteling's lemma. So these are critical skills of an economist. If you don't have those skills, then you are not really an economist, right? So you must therefore be good at those things. Yeah, and that's why we are going to spend a lot of time essentially helping you learn those Roy's identity, Shepard's lemma, how to derive demand functions, how to do optimization, yeah, how to understand model human behavior. And the next semester we will look at strategic behavior. Here we are just looking at simple individuals. But when individuals interact with each other, when firms interact with each other, and when their decisions are interdependent. So for example, what one firm does affects other firms, right? Then you will look at interdependence of decisions. And that is where the next tool of game theory will be useful to us. Right? So our next microeconomics will essentially, our first semester microeconomics essentially about optimization. Indirect utility functions, expenditure functions, profit functions, Royal identity, Shepard's lemma, compensated demand function, uncompensated addiction, Marshallian. There are things that you, and a final general equilibrium kind of an idea. Right? Okay, general equilibrium and some welfare theorem is what we do. In the second semester, you will start studying what happens when there are people who are strategically interacting with each other. So their game theory will be but also an optimization. Right? Everyone trying to maximize their behavior. So how to model individuals in a strategic interaction will be the different types of learning. Right? So you must be, to be a good economist, understand both those things. Yeah, so therefore please make sure that you, and that's why we have tied this year the math eco course very strongly to these microeconomics skills that you should have, right? Okay, so now we are going to talk today about the econometrics part. So we said yesterday that it's important to know whether a given time series is stationary or non-stationary. When does a time series become stationary? When its mean is constant, when its variance is constant, and when the covariances do not depend upon time. They might not be constant, but they should not depend upon time. Right? Covariances will not depend upon time. Right? Covariance should not depend upon time. Sure? So for example, take a simple case. Suppose we have yt is equal to phi yt minus pt. And the absolute value of phi is less than 1. What is the expected value of yt? Can somebody tell me? What is the expected value of yt? So you first will do is backwards. What is generally yt is equal to alpha plus phi yt minus plus pt में expected value of yt क्या था? Alpha upon 1 minus phi. What is the value of alpha here? What is the value of alpha here? 0. So if alpha is 0, what will be the expected value of yt? What will be alpha upon 1 minus phi? Alpha minus phi will be 0. Right? As you can see, can you prove this properly? The way to prove this properly is to do the following.
plus
Yeah. Yeah? Sure? If you do this again, what will you get? So you substitute yt minus 2 here, right? Sure? If you do these j times, what will you get? 5 is to j. Yt minus j. Right? Plus so on. Right? Sure? As j tends to infinity, what will this be? As j becomes larger and larger and larger, what will happen to 5 is to j yt minus j? It will tend to 0. Because 5 is a number less than 1 is absolute value. Right? So this process will be, this can be written as so. What we expected value of yt now? What is the mean of yt here? What we expected value of yt? Yeah. Simple 6. So what did we expect value of yt? Yeah, but what is the expected value of that whole sum? So can you tell me what is the expected value of yt? This particularly सांगायला पाहिजे होती. You guys should tell it quickly. काय एक्सपेक्टेड वाईटी काय होणार? माहित नाही. तू ग? नो आयडिया. Mithila काय एक्सपेक्टेड वाईटी? 0, right? Why 0? Mithila is right. Why is it 0? 5 is not 0. Expected value of et is 0. Again, expected value of yt right? And all these expected values are so, yeah, sure. Whereas, okay, I will set you a challenge. Suppose the model where again the absolute value of 5 is less than 1, right? Again, we are showing prove to me without looking at the notes yesterday that How will you prove this? Prove this. फक्त backward substitute करायचं आहे, अजून काही नाही. You have to keep on backward substituting and you will get the solution. So do that. So try to do this. झालं? ट्राय तर कर. Yeah, you can derive it. How many of you can derive this? 1, 2, 3, 4, 5. सूर्यनगर कोण आहे देणार? यार येत आहे ना? हो गया? Right? How do you do this? Just 4 of you are getting this. 4 or 5 or 6 of you. There's about 10% of the class that's present here. कर कॉपी नको घ्यायला. तू तिला सांग कर तो काय How many of you can get it now? How many of you got this finally? Oh, good. So now I can get solves. See.